Good afternoon, learners. That Tshaka, your physical science teacher at the ETSA Educational Project Center of Distinctions. So for today, I'm going to introduce one of the most important topics in physics for the grade 11 learners by the name of electric circuit. Remember that this topic, you will be doing it in grade 11, and then electric circuit is also part of grade 12 syllabus. So please make sure that you understand it. Please make sure that you research more about it, because of there are more marks that you can accumulate so that you can pass. When you get to grade 12, for term 1, it is going to be assessed in June, trial examination as well as final examination. But for June examination, the electric circuit that you'll be doing there, it will be the same as that one of grade 11. But when you reach your November, even your September trial examination, there will be an introduction of internal resistance. But for grade 11 and grade 12 for first semester, you won't be able to, the internal resistance won't be assessed, but it will be assessed when you get to your trial examination and your final examination. So the study of electrical circuit is essentially to understand the technology that uses the electricity in real world. And remember that we depend on electricity and electrical appliances to make many things possible in our daily lives. This becomes very clear when there is a power failure and we can't use the kettle to boil water for tea or coffee. We can't even use the stove to cook our dinner. We can't charge our phone to fill in our batteries. We can't even watch TV or electrical lights. So as we know that at this point in time we are facing problems of load shedding, this simply tells us that if we learn this topic very well, we might be able to know how to solve the problems that are related to load shedding. So please let us get started. Before I talk about Ohm's law, I would like us to go back to grade 10 and grade 11 to grade 9. Let us remind ourselves about the symbols that are appearing on our screen. And then again here, let me just have this one V, and then this one yeah. What is the name for this one? This one, we call it a cell, and then combination of cells, we call it a what? A battery. And then what's this one? This one is a bulb. This one is our bulb. And then what is the name for this one? This one is our ammeter. Ammeter. This one is our voltmeter. Voltmeter. This one is our resistor. And then this one, closed switch. And then this one is our electrical conductor. Electrical what? Conductor. Okay. For now, my beautiful learners, we are going to focus more on the one that I am ticking. When we are talking about an ammeter, ammeter is an instrument that we use to measure the current that is flowing throughout our circuit. Ammeter is an instrument that we use to measure the current that is flowing throughout our our circuit. And then when we talk about a voltmeter, voltmeter is an instrument that we use to measure the voltage or the potential difference in our circuit. And then again, we are also having a what? A resistor. We are saying that a resistor is a measure of how hard it is to push the current through a what? A circuit. Obviously, in our circuit, we must be having a what? A battery. We must be having a what? A conducting wire. The function of conducting wire, I can say that, is to make sure that the electricity pass through. That is why we are using electrical conductor. And then obviously sometimes we can be using the bulbs to show if the electricity is there, because immediately if we connect the bulb and then the bulb lights and then our switch is closed, it will indicate to us that there is an electricity in our circuit. So obviously here we are having a closed switch. Obviously, my beautiful learners, these are just the instruments that we'll be using to construct a circuit. It can be series circuit or it can be parallel circuit. But before I continue, let us just recap. When we are having a series circuit, what are the equations that we use to calculate the total resistance, to calculate the total current, to calculate the total voltage? In series circuit, we are saying that RT is equals to R1 plus R2 plus R3. Yes. In terms of I total is equals to I1 is equals to I2 is equals to I3. This is just part of revision. Remember that for now we are busy with grade 11 curriculum. So I hope this one you did it in grade 10. And then in terms of V total we are saying that is V1 plus V2 plus V3. This one is for series. What about parallel? For parallel, let us remember that for parallel we are saying that parallel circuit, if I want to determine the total resistance, we are saying that 1 over RT is equals to 1 over R1 plus 1 over R2 plus 1 over R3. Yes. In terms of I total is equals to I1 plus I2 plus I3. Yes. And then in terms of V total is equals to V1 is equals to V2 is equals to V3. For parallel connection, we are saying that here we are going to have the bulbs or the resistors that are connected in parallel. So it shows that in terms of current, our current for parallel connection, our current will split. But remember that in terms of potential difference across parallel resistance is what is the same. Okay, now let's check, my beautiful learner. This is just part of grade 10 work, so I wanted us to have that kind of information so that when we continue we don't leave anyone behind. So Ohm's law, we have three quantities which are fundamental to electric circuit, which are current, voltage, sometimes voltage is referred to as potential difference, and then resistance. What is electrical current? Electrical current is defined as the rate of flow of charge through the circuit. Electrical current is defined as the rate of flow of charge through a what? Through a circuit. Remember that we are having this formula that says I is equals to delta Q all over delta T. This is the equation that we'll be using to determine the current that is flowing throughout our circuit. And then remember that, my beautiful learners, in the circuit, our battery is not producing the current, but our battery is producing the charge that are flowing throughout our what? Throughout our circuit. And then obviously we will be having a time whereby we are recording the flow of charge. That is why the flow of charge, when we divide it with our time, that's when we get a current, which is the rate of flow of of charge. So some other people, they are confusing it, saying that our battery is the one that is producing the current. Our battery is not producing the current. Our battery is just releasing the charges, and then those charges, we divide them with our time, the rate at which the charges are flowing at a certain time, at a certain point. And then when we divide that charge with the time that is given, and then that's where we get a current. So that is why we are saying that current is defined as the rate of flow of charge. Even when you check this equation, I is equal to delta Q over T. Yes, that is that. That's where we are using an ammeter in our circuit to do what? To measure the current that is flowing in our circuit. I hope that you understand it, guys. So electrical current is defined as the rate of flow of charge through a circuit. Okay. Now when we are talking about number two, we are having potential difference. Potential difference I can just refer to as the battery or a cell or a voltage. Potential difference or voltage V is the amount of energy per charge needed to move that charge between 2 points in our circuit. Meaning when we talk about the potential difference, we are saying that is the amount of energy per unit charge. Is the amount of energy per unit charge. That is why when you go to the shop to buy a battery, we have different kind of batteries. There are the ones that are written 9V, there are the ones that are written 12V, there are the ones that are written 18V, and so forth. So it shows that the size of the battery, they are not the same. The size of the battery or the cells, they are not the same. So that is why here we are saying that the potential difference is the amount of energy per unit charge. So it shows that the one that is written 9V, it will be releasing the charges at a certain rate. But if I have the one that is written 24V, it shows that one, it releases more charges compared to that one of 9. So that is why we are saying that the amount of energy per unit charge. The amount of energy per unit charge. And then we are also having the resistance. The resistance is the measure of how hard it is to push the current through through a resistor element. Remember that for series, when we determine the total resistance, we use RT is equal to R1 plus R2 plus R3. But for parallel resistance, we are saying that 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. It will depend on how many resistors are given. Okay, so now we will look at how these three quantities are related to each other in electrical circuit. An important relationship between the current, voltage and resistance in a circuit was discovered by Simon Ohm, and then it is called Ohm's law. It is called what? Ohm's law. So now, my beautiful learners, let's check. Let us state Ohm's law. Please write it down. Ohm's law states that the potential difference across a conductor is directly proportional to the current at a constant temperature. The potential difference across a conductor is directly proportional to the current at a constant what? Temperature. Please underline constant what? Temperature. Potential difference is directly proportional to the current at a constant what? Temperature. So for now, we are checking the relationship between the potential difference and current. We can see that the relationship between potential difference and current is that they are directly proportional. Meaning, when V increases, I will also increase. Why? Because they are directly what? Proportional. And then again, when we're talking about temperature, the main reason why in this situation that we are saying that temperature must be constant, it is because of the temperature is one of the factors that influences or that affect the resistance of what? Of the resistor. So if we don't keep if you don't keep the temperature constant, therefore the resistance will keep on what? They will keep on changing. So meaning here, when we are saying that the temperature must be constant, we are referring to the what? To the resistance, because we don't want the resistor to do what? To keep on changing. Because now we are checking the relationship between the two things, which is potential difference and current. Obviously, when we check the relationship between the potential difference and current, we must make sure that we keep the resistance what? Constant. So in this situation, what keeps the resistance constant is our what? Is our temperature. So that is why we are saying that we must make sure that we keep our temperature what? Constant, so that our resistance cannot change. So now let me just make an example to make you guys understand what is happening here. I'm having two circuits. I hope you guys are following. Here is our ammeter, and then here is our bulb. Our bulb is 9 ohms. Even this side I'm using 9 ohms. Why am I using 9 ohms? It's because of I'm keeping the voltage, I'm keeping the resistance of circuit A and circuit B what? The same. I'm keeping the resistance of A and B what? The same. But as we can see, here our battery, let me just say our battery here is 9V. But for this one, our battery, I'm going to use 18V. I'm going to use 18V. According to the formula of Ohm's law, we are having the equation that says equations of Ohm's law. V is equals to IR, where V is the potential difference, I is the current, and then R is our resistance. So if I want to make I subject of the formula, obviously we are going to have I is equals to V over R. And then lastly, if I want to make R subject of the formula, I'll be having R is equals to V over R. So now, let's check. I want us to prove this law. Our R is constant, is 9 ohms on both circuit A and circuit B. So let us determine the current on this diagram. The current is I is equals to V over R. What is my V this side? My V here is 9. And then what is my R? My R is 9. So when I divide 9 by 9, our answer is 1. Remember that current is measured in what? In amperes. So this is what we have. And then number 2, let us come here to determine the very same thing, to determine the current that is flowing throughout our what? Our circuit. So I is equals to V over R. What is our V? Our V here is what? Is 18. And then what is our R? Our R is 9. Now 18 divided by 9, it gives us 2 amperes. So I hope that you are following. What is happening here? From here, from circuit A to circuit B, what happened? We increased what? V, which is the potential difference. Which is potential difference. And then what happened? When we increase the potential difference, our current also increased. Provided that what? Our R, which is our resistance, what? Remains what? Constant. I hope you guys, you can see what is happening here. So let us go back to Ohm's law. Ohm's law states that the potential difference across a conductor is directly proportional to the current at a constant what? Temperature. Why constant temperature? Because temperature is a factor that influences the what? The resistance of a resistor. I hope it makes sense, my beautiful learners.